Cool. All right, so Kevin from Subies, and then we've got a couple of the members of Subies in the Rotary group here. Of course, I'm Seth from Gaijin Tuning, and today we're going to talk a little bit about standalone versus ECU flash or ROM tuning, and kind of hit on that. I myself, huge fan of standalones or proper ECUs. Kevin deals a lot with ECU flash, Subarus.
He already did a stab. He said proper ECUs. You hear that,
guy? So, yeah, one of the first things we'll kind of talk about is processing power, right? Mm-hmm. And this goes back across a lot of different cars in the JDM world. Now, admittedly, Subarus and Evos both have had huge success with their ECUs being able to be flash tuned. And that goes into the community support on definition files, which we'll talk about here in a little bit, as well as the actual processors that Subaru and Mitsubishi chose to put into their OEM ECUs, right? With that, there's some drawbacks as well on that we'll discuss as we move on. So quickly, I'm just going to cover, if I can, where is it? Not showing up is where it is. Hold on. Give me just a second.
So while you're looking that up, I'm gonna bring this up a little bit because the original like reason why you thought about this was because I said it's like the ECU flash is like, I believe it's more okay if you're on more of like just a turbo injector build, because to me the price to what you're getting versus what buying a whole ECU versus just flash tuning for just a turbo injector thing, you're going to get the same result, but you're going to spend way more money on that.
So we're going to talk about that too, and I'm not saying that you won't get great results, but there's a lot more that goes into it, and you're paying for a lot more than just the injector results.
Yeah. Obviously, the aftermarket like standalone has all those safety features, like to where if your air fuel runs too lean, it'll like all those shits. Obviously, I'm blanking on what they are now, but
all right. So to kind of go into that, or kind of get started with that, right? Let's talk about this. So 8-bit, 16-bit, and 32-bit ECUs, right? Everyone assumes, or the general person is going to assume that an 8-bit is half of a 16-bit, which is half a 32-bit processor, but that's not how it works. And what you're talking about is input output. You're talking about addressing addresses, or how many addresses that you can have within the processor itself, as well as how much random access memory or rapid access memory is available to that ECU, right? So an 8-bit ECU, and some examples I have down here are the Series 6 FD3S, right? The Series 6 FD3S used an 8-bit ECU, as well as the earlier model FC ECU, if I remember correctly, was also an 8-bit. So with that, you only have 255 addresses. So it can only process 255 different commands at a time, essentially, right? Or 255 bits of RAM is its header cap. That's the cap that the ECU can actually use. Going to a 16-bit, which is the later model FDs used, as well as most of the Subarus that you see listed there, the 02 to 05 USDMs, the 01 to 07 JDMs, as well as the JDM STIs, were 16-bit ECUs. So that goes all the way up to 65 kilobits of RAM, right? Or 65,000 addresses. So you can see a huge difference in actual processing power. Does anyone have any questions kind of on that and why it would be important in this instance?
Not at this moment. I kind of joined in a little bit late.
So the point being, right, and then down here also, your current Haltech Elites in your Nexus are all using a 32-bit processor. So again, massive more amounts of memory over even a 16-bit ECU. So that we already start to see our first differential there between reflashing a 16-bit ECU versus using a dedicated aftermarket ECU that might be using something like a 32-bit processor, right? Up to 4 gigs of RAM versus 65 kilobits of RAM. And you can compare that to your home laptops or your home computers. No one wants to use 65 kilobits of RAM. You can't even do anything with that anymore. 4 gigabytes lets you get a lot more bandwidth and processes sequentially running. And then you get into like multi-core processors and things like that, right? I do not claim to be a computer genius when it comes to the hardware. If anyone is, feel free to chime in and ring in on that. But that's essentially what we're talking about, is how much quick access or RAM memory you have available to you for things like data logging, live changes, processing of data, of sensor data, oscilloscopes like the Haltech has built in, et cetera, et cetera. And that's why you don't see a lot of the 8-bit ECUs also being able to be reflashed easily.
Yeah.
So I will stop sharing that slide for a second.
Seth, go ahead and give us a couple of examples. Like you mentioned a few things like data logging and certain things like that, like oscilloscopes, like the newer Haltech NSP runs and whatnot. But on a standard ECU, like what type of benefits would you see from like an 8-bit, 16-bit, 32-bit?
So
if that makes sense.
Yeah. So again, it's going to be so like an 8-bit ECU, and I was just actually reading an article on this as I got ready for this meeting. 8-bit ECUs basically there is no reflashing. They're not fast enough to actually write back into the chips. The infrastructure was just totally wrong at the time, right? Of 255 bytes. So there was a guy that did a reflash or he modified an FC3S ECU to be able to be flashed, kind of like using ECU flash. But he had to completely get a new chip. He had to get a new socket set put into the board itself. He had to get a custom motherboard. So 8-bit, you're really at bare bones, right? And then at 16-bit, you have all the different addressing. So resolution on the tables, how many tables you can have, PID control, right? Basically closed loop. So you have data coming in and data going out of the ECU at a more rapid rate. That's kind of how I would put it in a nutshell, if that makes sense. Yeah, and then 32-bit, you can do more and more and more and more, right? Just like your laptop, the more RAM you have or the more memory allocation you have, the more things that you can do all at once.
Good.
Child.
Hey,
all right.
Put that kid to work. He's slacking.
All right. So getting into the kind of meats and potatoes of this discussion. And Kevin, jump in here wherever. These are some of the points that I kind of thought of earlier, and I sent you a copy of this before we started this. So with the reflash, one of the things you have, and these are both pros and cons, it utilizes the OEM ECU, right? And that's designed for a single chassis. So that computer was designed for that car or that series of cars, and that's it. And there's hundreds and hundreds of hours that went into those startup maps, the closed loop PID control, the traction control computers on some of these, the CAN bus system for the entire dash on newer computers, et cetera, et cetera. Thomas, you hit on it earlier, the low cost, right? It's much cheaper to buy a Tactics cable and hit a low cost reflash on your stock ECU. No one's really arguing that. Definition files, we will keep discussing, we'll keep coming back to that. And that's when you get into your stock ECU, you're relying on a definition file or someone who have gone in and reverse engineered the hexadecimal or the encoding that the OEM manufacturer put in to identify those tables, develop those tables into a usable graphical format for the tuner to modify. Processor speed, we just touched on that, 8-bit, 16-bit, 32-bit, you're kind of stuck with whatever the OEM manufacturer gave you. You can't really go in and resolder it unless you're at a whole different level that I'm not at. So it retains the OEM CAN bus. And this is really getting into a lot of the more modern cars. Europe is a great example that doesn't have a ton of aftermarket support, right? You don't see a lot of plug and play ECUs for a lot of these Euro cars. And it's because they were some of the first to adopt this total CAN bus system. The dash is CAN bus, the traction control computers are CAN bus, ABS, tire pressure sensors, right? And this is all tied into a CAN bus network, which is sharing data over a 2-wire twisted pair back to the ECU, and that's distributed back to everything else along that bus line, whether it be the dash or the inputs from the radio or the aircon, whatever, right? There's no more really you push the button and that triggers an actual relay that sends a signal down to whatever. No, it's coming over CAN bus to tell circuits turn on and off. Expandability. You are stuck. Whatever that OEM ECU has, that's what you can have in it, right? There's not really additional AVI inputs and outputs easily available. Wiring in a wideband can be a whole thing depending on the ECU and the software that you're using for the reflash. And then, of course, PID tables and closed loops. So I'm bringing this up because the new GR Yaris is a great example of this, right? The new GR Yaris, and I'm sure Matt will get angry at me for misquoting this, but it has something like 400 PID closed loop controls across the ECU, right? From tire traction to wheel bias, differential bias rather, boost closed loop, fueling closed loop based off air temps, coolant temps, etc. So going back to the definition files, if you were to try and go in and say use a open source support for reflashing a Yaris ECU, if that could even be done, you would be relying on someone that had reverse engineered the hexadecimal or the encoding that Toyota had put on the ECU and hope that they got all of these PID tables and closed loops identified and properly developed out. And we'll touch on this in a couple slides later on the Win OLS when I talk about how that's kind of done. Now, if they had missed one of those tables or they had misrepresented one of those tables by identifying that data, right, or the scalar, then you could be missing a PID. You could be throwing a PID closed loop control off. You could be altering data incorrectly, right? And you have no way of knowing that because, again, it's reverse engineered, not purpose-built dedication like a standalone. And I'll kind of open the table up real quick if anyone wants to jump in on some thoughts with this, or Kevin, whatever you have to say on this.
Yeah, no, I mean, it's yeah, I think you're doing a good job on breaking them down and whatnot. You know, like you said, you're stuck to a specific platform. If you think about Subarus, for example, a boxer style engine, the way the cams are set up, even in the platform 16-bit versus 32-bit ECUs, you have situations where you have a cam and a crank sensor, right? And that's kind of like the Haltech's home and trigger, right? And then
right,
what is it? Home and trigger, right?
Home and trigger.
Yeah, and then so you have something along those lines, except for 32-bit, you use like a different style cam. There's no way that you're going to be able to. I mean, granted, there's also not too many reasons why you would probably want to, but you know, you're not going to be able to put that in any other type of vehicle, right? It's going to be stuck in a Subaru. So,
right.
Yeah.
And you kind of hit on it. There's limitations, right? What you can do for a Subaru based off the definition file and the ROM that you have between ROM Writer and ECU Flash, there's things that you can do. Say, let's anti-lag or two-step, right? Launch control. Mm-hmm. You may be able to, someone may have hacked the computer or hacked the code to be able to enable that, but it's still not purpose-built. So it's not going to be quite as effective, I guess you could say, from a tuner's perspective.
Yeah. So it's very limited.
Yeah. So it's limited. It's limited in how you can implement it. It's limited in how much can you pull, right? Because again, there's limitations within that OEM ECU based off all those other closed loop tables that are going to let you really make these big changes.
Yeah, I mean, for even like anti-lag, it's kind of a tough one to crack, because even if you think about like Haltech's anti-lag or Subaru's the Carberry ROM's anti-lag, I mean, it's really aggressive negative timing on decel. It's not, you know, if you look at the rallies and the way that their anti-lag is actually properly set up with some type of access air into the exhaust manifold, it's a completely different monster. But when you think about it that way, yeah, you have, that is something I do like about the hacking, you know, portion of it. You know, you have some pretty brainiac dudes who have built things like Carberry ROM, which on an OEM platform, which is 16-bit ECU, all the cars that we're tuning right now have this anti-lag. They have launch control. We have also dual mapping, where we can actually use two different style maps, two different ignition tables, fuel tables, speed density. So we have VE tables and things like that. So you are limited in some sense, but at the same time, because it is somewhat of a basic platform, not basic for me, but basic enough for you to hack and then also add different features into it. Also, it's you know, the patching, I guess you would call it. Even in the 32-bit ECUs, these guys are patching new things to be able to run speed density and things like that. But you're going above and beyond and expanding the ECU, and that's you're still hitting limitations compared to like an aftermarket ECU that is generic sensors and all kinds of crazy stuff that you could do. Anyone can do it. You know, the average layman can get into the ECU and do that. You don't have to be this brainiac, code, hacker to figure that kind of stuff out in the Haltech stuff. And you can go to YouTube and figure a lot of the stuff out. So I see the pros and cons. It is cool that there are things like that in the Subaru world where you can actually get these different patches and whatnot too, however, though. So kind of.
Yeah, and I want to be clear, like by no means am I saying that you can't get a great tune or get some of these effects that you're looking for.
Yeah.
On Evo's scan, for example, there's Evos out there running over 1,000 horsepower on the stock ECU. Yeah. It's not saying it can't be done. It's just saying that it may be a little bit more painful and there may be some limitations that you didn't expect, right? And knowing the software comes into anything standalone or reflashing, but also identifying the risks that you're taking, because if you're not one of those brainiacs like you're talking about, and you're not the guy hacking the hexadecimal or reverse engineering the coding, you are trusting, again, that somebody out of the goodness of their heart spent all these hours reverse engineering this coding and gave it to you for free.
Yeah.
Right. And that they were sober when they did it and they did a good job. Right. Yeah. I mean, if you really want to just throw it out there like that, I guess, kind of comically. So now we'll beat up on the standalones for a minute. Yeah. Because I'm an equal opportunity hater.
I'll say, I got a question for you.
Yeah. What's up?
Hey, so as far as recording diagnostics, which one would you say would be easier?
So most of the flash tuning, right? The ROM rating, ECU flash, you can do some data logging. And different platforms are better than others. Again, I'm not specifically talking about Subarus or Evos here. I'm talking about reflashing as a whole.
Yeah.
Right. Data logging is not necessarily inherent. You're using intermediary software. So, for example, on Subarus, I know for a fact you have to use ROM rater and ECU flash together, right? Sequentially, basically, because one will pull the definition files or pull the ECU program. One does the data logging. One allows you to edit and then rewrite back. Kevin, correct me if I'm wrong. I know it's out of order there.
People some editing on ROM rater also, but it's very few. Yeah, most 9 times out of 10, it's exactly that way. Yeah, you're reflashing and editing with ECU flash, data logging with ROM rater.
Yeah. So did that answer your question, Rob? Kind of on that. It's because it's not dedicated. You may not have as much control on what you get from that data log.
So standalone is a lot easier to data log than flashing.
It's more purpose built for it. So you'll definitely have access to all channels within the standalone. Even some channels you may never need, right? And some engineer might need, but you don't. You'll have access to it because it was designed in the software for it, designed in the hardware. Versus a standalone, again, you're relying on a third-party software to interpret the data coming out of the ECU.
Yeah, I would say probably 90% of what we do at Okie Subies is all doing reflashing, ROM rater, ECU flash, all that stuff. And I would still say aftermarket ECU standalone on a data logging aspect is so much easier and better. Like, so I have to take ROM rater, I have to add certain parameters, data log it. I upload that data into something like Megalog Viewer, which I have set up tables to be able to adjust the ECU. Then I go back into ECU flash, make adjustments. Then I have to upload the ECU. And it's just a timely process, and it's just a one-by-one type thing. There's no real quick way of doing it. As to, for example, my car, the Legacy, I could have tuned the 32-bit ECU that I originally had on there, but I have a Haltech Elite 2500 in it also, and you can data log everything. Like, I could set it up where I can wide open throttle, and as soon as it hits 100%, it starts data logging for X amount of seconds or something. Like, you can't do that with ROM rater. So there's so many different, like Seth is going to end up touching base on, is the options and the limitations on the OEM platform versus Haltech. Yeah, the Haltech is just so much easier. And then live adjustments that you can actually make right there based off of the data. I'm not going to get too far into that, Seth, but yeah, that's
a hit on that. Yeah.
Other thing that is just so, yeah, I would say, even though I do 90% everything with OEM ECUs, I would still say, yeah, the Elites or just standalone in general is just so much easier and just better in general when it comes to data logging.
Yeah, so we'll jump over to the standalone column, right? And let's talk through those. They're built for a universal application. And when I say that, yes, there are plug and play models, right? Everyone remembers the Haltech Platinums that were plug and play, purpose built. The Elites have the jumper harnesses that make them plug and play. M-tron has some plug and play setups for the Evos and the GTR specifically. Come to mind, some of the MY 05 Subarus, I believe, also have an M-tron plug and play potentially off memory. But everyone has seen plug and plays. But at the base of it, in the software and the coding of it, it's built for a universal application, right? I can go in from scratch, tell it what triggers I'm using, how many teeth, missing teeth. I can give it my injector data, fuel table. There's nothing predefined. Yeah, everyone can agree with that.
Yes.
It's built for any car. You define that in your base maps. It's potentially a higher cost. And I say potentially because I know everyone right now is thinking, oh, $200 for a tactics cable, free ECU flash, et cetera, et cetera. But that's not always the case, right? Go back to the European cars I was mentioning before, and you may need something like a KES V3 with a titanium tuning suite, which costs thousands of dollars, right? Maseratis, Audis, and I'm going to list some of these other tuning platforms down later. So potentially a higher cost for the standalone, but at the same time, getting the flash software to use the OEM ECU may be just as expensive as going standalone in some applications. So it's kind of a mute point there between the two, depending on your specific chassis or your specific point. Support. So I think this is a huge one. If I have a problem as a Haltech dealer, or you have a problem as a Haltech customer, or an AEM or M-tron or Link ECU, whatever, you can pick up the phone and you can talk to somebody at Haltech.
Yeah.
If your hardware dies, you're covered under a warranty to an extent, or you can send it back for repair. Toyota, Subaru, Mitsubishi is not going to take their ECU back after you hacked into it with a tactics cable. Right? You're not going to call up Toyota and be like, hey, man, I'm hacking your software with a definition file that I got to resize my injectors, and I was wondering if you could give me some pointers. Like, you just don't have that support with the open source stuff. Proper race functions, we touched on that. You know, it's purpose-built launch control, it's purpose-built anti-lag in the fuel model, in the Haltech software, in the M-tron software. Torque management, throttle body modeling, right? Torque by demand. All of these things are purpose-built by that ECU manufacturer to work in their software, work with their fuel model. As to where, like Kevin was saying earlier, yeah, you may have anti-lag for the Subaru for that specific ROM or that specific definition file rather, but it's going to be a patch. It's a hack that someone wrote into the code. Right? Construction. I brought this up because how many OEM ECUs have you seen that are IP67 rated for dust and water? Personally, I can't think of any. They're usually aluminum cases with some screws holding them shut, and that's it. As to where a lot of these modern aftermarket ECUs, these standalones, are IP67 rated for water exposure, for dust, for dirt, right? So that they can be installed in dune buggies, Dakar rally cars, motorcycles, actually, to an extent, for like the drag race bikes. So just something to consider based on your needs and your requirements for your build. And then resolution. So resolution of a map. Haltech right now, I think, is 32 by 32 on their fuel maps from memory. Maybe bigger now with NSP. I haven't checked lately, actually. Versus, you know, some of the cars out there might be 16 by 16. I saw a definition file earlier this week while I was getting ready for this meeting, and the map was literally like 4 by 4. So 16 cells total. Right, so you don't get a lot of that resolution. Also, you typically cannot redefine your axes on a reflash. So if your idle is at, say, 800 RPMs, but your cells in your reflash map in your definition file are 500 and 1,000, you can't go and just add on a lot of computers a cell for 750 or 800, so you can pinpoint, target, and tune that specific spot, right? Or if you have staged fuel injection, you can't go in and start adding your new columns and changing your axes around to fit where your fuel stage is on, if that makes sense. So you have a little bit more refinement, a little bit of control, in my experience with the standalones.
Yeah. Subarus, you can adjust them a little bit, but you're 100% when it comes to the amount that you can actually do. Because you can do, like, Subaru has, I can't remember off the top of my head, you know, so if you're not familiar with Seth's talking about right now, you have left side, RPMs, top side, load or boost or something along those lines, right? So if we're tuning something from 0 to 8,000 RPMs and on top from whatever negative to however PSI you want to do, you can dial those in and get down into really specific things, because you can make those Haltech ones like, yeah, what is it you said, 32
by 32, so what's that, 644 cells, something like that, off the top of my head. That's probably wrong.
But still, I mean, if it's anywhere near that, yeah, the OEM platforms aren't anything near that. And if you do, you're gonna kind of sacrifice, if you will, somewhere else, because you only have a certain amount, right? So if you're trying to dial in this much more and you're adding, I don't know, 500, 750, 1,000 RPMs, you're going to lose the amount that you can do up top, if that makes sense, right? So you're not going to be able to do up top. You're going to have to end up doing, I don't know, 2,000, 7,000, 9,000 RPMs type of thing. So, I mean, we don't have too many issues like that, honestly, with Subaru, just the way that they have. One thing great about the Subaru platform is the amount of people that are tuning on the Subaru platform, and like the OEM, like it's not like I mean, I hate the way that Seth always puts it as hack, right? Because it makes it sound so, I mean, I get it. However, it's like for Subarus, it's not typically an ECU that is more unknown and doesn't have a lot of support or people using it, and then one person hacks and then let's just try it out. Like, it's typically like with ECU flash, a definition, and then you have or Carberry ROM will even say, because that's usually what we use, and you have just thousands of people who are testing it and using it, and it's just developed over the years, and it's actually a pretty solid platform now, which goes back, well, what about in the very beginning? And you're trusting this guy that it's going to be right, and that would be going back towards what Seth was talking about, and he'd be 100% right. So I just say that we have the benefit of getting the tested and dialed in product, so now it's not so much of a problem. But yeah, I hear the hack word. Yeah,
I totally agree. I mean, at the end of the day, I use the word hack because that is truly what it is, right? By the definition of hack, someone reverse engineered it, not in a derogatory way. Because yeah, Subaru and Evo, like I said before, come to mind. They have great community support in this, right? So does it negate the support kind of benefit that I have for standalones listed? I would still say no, because there's no dedicated manufacturer, right? But community wise, you have a ton of genius people that can, dial in and support you. There's forums, Facebook pages, I'm sure, dedicated to it, et cetera. So there is support in that sense. And you're right, for Subarus, it is pretty well defined.
But arguably, it's the same thing with Haltech, right? So there's that same community of people using it and diagnosing and helping people out, and hey, I had this issue, and so you're gonna get, it's the same thing with Haltech also. Even like you said, on an even bigger level, because their customer support is
I mean, I can always call Haltech, right, or Mtron or AEM or whatever. One thing that I wanted to touch on that you just brought up that I kind of overlooked when you were discussing the axes, right? So RPMs versus fuel load, and you said load, which is a great point. So in Haltech, I can set those axes. I can tell which data channel I want each axis to be, right? RPM versus fuel load, or map pressure, or EMAP, however I want to set my map up, throttle position sensor, right? And it brings up the point because the guy I mentioned earlier that reverse engineered the FC3S ECU, he was able to define the maps. And he defined the ignition maps, both for leading, trailing, and split within the ECU. However, the top axis was exactly that, fuel load. But it was numbers that didn't really correlate to any specific thing, right? So when they're reverse engineering it, how do you decide if it's grams of air because it's using the MAF, or how do you decide that it's the map? Or is it an arbitrary mathematical formula somewhere else in that ECU using both, right? How is the OEM ECU defining fuel load when it's getting reverse engineered? And so while we had the FC OEM ignition tables, we had no way to actually reverse map that. Or I say he didn't, and now the rest of the rotary community, because we don't know what Mazda meant by fuel load for that specific table.
Interesting.
It's kind of I guess, reinforcing the point of definition files, right? And someone else having to reverse engineer them means they need to figure out what those axes are as well correctly. Which brings me up to input outputs. Oh, by the way, on resolution, I was wrong. That is 1024 cells, something like that. Anyway, input output. We mentioned it. We touched on it earlier. Try adding extra sensors like fuel pressure. oil pressure, things like that don't exist in the OEM ECU into the OEM ECU.
Yeah.
9 times out of 10 can't be done, right? So there's really no expandability in that sense of adding additional sensors, as well as you're kind of stuck on this, I would argue, your safety. So even if your definition file, if your patches allow for safeties to be set up, right? Like in the Haltech, you have multi-level safeties, DTC level 1 through 3, where you can control the actions the ECU takes if a piece of data goes awry or exceeds a limit that you set for it. You may not be able to do that in the OEM ECU. And if you can do that in the OEM ECU, you're limited to the sensors that are installed in the car with the OEM ECU. You can't go adding sensors easily into it. And then real-time updating. This, to me, as a tuner, is probably the biggest thing. When I'm sitting on a dyno with a Haltech or an Mtron, and I'm looking at my target lambda versus my lambda, for example, on my fuel table, and it's 3% lean, I can hit P for percentage, hit 3, hit enter, and it automatically changes the fueling. And I can see that change in real time, which makes tuning way faster. If I'm doing it with ECU Flash or another reflashing software, I have to go, okay, this cell is 3% lean. I have to make the change, stop the car, save the file, write the file to the ECU, which can take some time, restart the car, restart the dyno, go back to that cell, and verify that the change was effective. Every time.
100%. Yeah. I mean, that's even kind of like being generous about it. Like, for example, Subarus, I think Evos too, they have the jumper cable. You guys, you're right. So, and then you have the green connectors. So before I can even get the ECU into reflash mode, I have to put the jumper in there. Now, as you're tuning, the jumper is usually in there. You just plug it in once and you're good to go. When we merge the cars, we delete that completely. But you still have to connect the green connectors, right? And then you upload the map, right? So you, like you already said, you've made your edits and things like that, and you've made your adjustments. And then you click upload, and then you ignition on. There's kind of a timing that you do, and then you let it download, upload into the ECU. So there's like even little connectors, and you got to disconnect the connectors after you reflash the ECUs there. So the steps there, that's huge. I was just doing it today when I was uploading a base map into the car that we just got done, and I was under there, and I'm trying to unplug the green, and I don't want to get out of the car, open the door, and get under there and unplug it. So I'm trying to do it with my hand, and it's you don't have to do that with an aftermarket ECU. Like you said, you literally just look at your long-term trims. It's 3%. That's okay. Cool. Let me just go ahead and add or subtract that 3%, and then you can literally see it right there, and you're going to be able to tell that it's correct. Versus when the ECU flash type setup, it's like, the temperatures and things like that. And there's a lot more when it comes to the OEM ECU. I love OEM ECU setups and the way that reflashing works. But yeah, when you're comparing, that's definitely a luxury when it comes to the aftermarket.
And I think it circles back to a few things on that too, right? To kind of circle back to what Thomas was talking about at the beginning of this, about the cost. Yeah, if you're going to tune yourself or you're trying to learn tuning, learning tuning on ECU Flash or ROM rating essentially, right, is just sounds horrible to me. To learn on that curve. But if you're doing it for yourself, then it's free. Your time is free, right? Your time is your time. But you have to calculate that time when you're paying a tuner also. It's hours of dyno time. It's hours of data logging and street tuning, depending on the tuner you're using. I know in Oki we have no dynos. I'm no longer there.
At this point, you're paying more to reflash than have a standalone.
Yeah, I think it could quickly go depending on how the tuner does it, right? Maybe some tuners are doing hourly rates, maybe some tuners are doing flat rates. Normally, and I would assume like Kevin here probably has a large collection of tune files that he's built over the years, same as I do over the cars that I've built. And so, you get a car and you go, okay, this has the same fuel system. It's using the same turbo, right? It's the same year, model, whatever. I have a base map, and it's still a base map because you still have to tune to that car's individually, but hopefully it's a lot closer. And so you save time with that. So it allows you to save the customer money. But again, circling back to what I was talking about with Thomas, if you're doing it yourself, you might save money. If you're paying a tuner, you may end up spending just as much as going standalone. give or take, right? And it's going to be tuner dependent. It's going to be shop dependent, your relationship with the shop, etc.
So, what about security?
And what do you mean by security, Rob?
Like, you know how a lot of people, you tune their car and they brought it back and said, "Yo, you screwed up my car with your tune," and then you find out that it turns out people messed with your tune. Can you adjust that with the OEM ECU flash versus a standalone on recording that?
So, yes, the answer is yes, to a point. There's a couple different ways to do it, right? It's a good question. So when you create a file, just like any file on a computer, you can do a checksum. You can do an MD5 hash of that file and save that MD5. That's one thing that I do, right? And now if the file's been modified at all, when I run the MD5 checksum on it, I'll know that the hash is different. It'll tell me the hash is different, and I'll know the file has been modified. So in that sense, yes. And I'll do that same thing with the ECUs I tune. As a rule, I do not lock my ECUs as a general rule. I have
But do you hash them to track that?
I also hash my files, yes, before I give it back to the customer. It's kind of my give and take.
Very smart.
A lot of tuners will lock their ECUs because they don't want exactly the liability that you're talking about. Someone decided they were a tuner one day, jumped in their Haltech, started pushing buttons, blew up their engine, and then says, "Hey, the tuner blew up my car." Well, I didn't. Here's the MD5 checksum kind of thing, right? Or some tuners are like, just stay out of it. I locked it, which of course goes into the whole locking versus not locking debate, which I don't want to get into here, right? There is no winner in that debate. Now, one thing I will say about the Haltech that I really, really like on this NSP updates is that you can lock only certain tables. So I can leave open all the stuff you need as a customer, right? Your diagnostics, your injector scaling, your whatever very basic things that you would need as a client to possibly go in and do troubleshooting or make minor modifications to your car. I can leave that unlocked, and I can lock things like your fuel table, your ignition table, and only lock those sections where you could cause actual like real damage to your car easily, if that makes sense. So that's a huge perk that I give to Haltech on the lock for that one.
That's cool.
Any other questions before we kind of jump on? Sorry, it's kind of a one-sided conversation.
So, how do you feel about like link? Because like currently, like I go back and forth because I am tuning my stock ECU once I do build motor, but it's not a permanent solution. It's just a temporary. So what would be like the huge differences versus like a Haltech versus a Link? Because Link will plug right up.
Right. I'm pretty sure Haltech makes a plug and play for your setup too.
Right.
But to answer your question, yeah. So I'm gonna get. I know when me and Kevin put this up on YouTube and I put it on my page, I'm probably gonna get hate mail for days now. But but I have no problem with Link. I tune Link regularly. I've tuned Subarus on Links back in Okinawa. I'm a Haltech factory dealer, so I use a lot of Haltech and I enjoy Haltech. So obviously I'm team Haltech. I am not a fan of certain aspects in Link. Their software hasn't been updated in I don't know how long. I think there was just a new revision. I haven't looked. I know they released a new model ECU. But the counterpoint to that is Link is rock solid, right? It is reliable. It is solid. It's well refined in the sense that they made something that works and they don't make changes all the time. And you kind of see that same business model out of high-end ECUs like Cyvex, Life, Bosch, Motec, Mtron. I think Mtron has like an annual firmware update and software update, right? Because they run it and they test it to death before they make it publicly available to everybody. And Link, I believe, is following kind of that same principle, that same model. Some things I don't like about Link, and again, this is going to be very like model dependent. This is my experience. Is I dealt with one Link in the past where I had to wire in the ECU. I used an ECU wideband. Customer had an AEM, and I had to bring in the AEM X series over serial into like AVI 3, which was the only AVI that would accept the AEM serial data. Like it was just a very weird setup. that I found on like the Link guides, and to me it was just very strange. The onboard map sensors, injector scaling in some of the Link software, I think that's been changed, but you used to have to do it kind of like a Power FC instead as a percentage of the OEM injector instead of giving it like an actual injector flow volume. And again, this is just my experience in the past. I could be wrong. It could have been updated by now, so please don't murder me on this. But I will go and say, like I said before, that Link is rock solid, right? I think Haltech has a bigger following at this point. With Andy Wyatt coming back onto the Haltech team after the buyout from Adaptronic, he brought over a lot of the fuel modeling that Adaptronic had, and you kind of see that coming to light with the NSP software at Haltech, and it's become very user friendly. I would argue that if you can't get your car running on a Haltech, you just need to read more, because it's very, very simple. It's very user friendly, and there's a ton of documentation out there. So I would encourage anyone to at least try a Haltech if that makes sense. Thomas, does that kind of answer your question? I know I kind of rambled there for a minute.
No, it does. So like mainly like my things.
He meant Haltech is better. That's just a kind of.
That's what I was getting at.
For you, Thomas. Haltech's better.
Yeah, trust me, I know. We've had plenty of conversations of him telling me how much better a Haltech is versus everything. Jesus himself could come down and tune my car, but he was still telling me that a Haltech is better.
I'm surprised that he didn't even touch basis into the customer support aspect of it too, right? So he's just talking about the technical aspect of what the product is. For me, when I never had any experience with either or, and I was asking the same question that Thomas was asking, I was looking into also the customer support basis of it, like what is the experience of the customer with their product. And, Haltech was always the one that came up on top. I'll give you an example of the first Haltech setup that I did. I put a legacy engine inside of a GC8. I had to do the full wiring and everything like that, right? I couldn't figure out how to get the car started. I was the guy, right? So, but it was also at this time I was doing a lot more of like the eTunes type stuff, right? Didn't know Seth very well either at that time, and I was just kind of like at the mercies of the internet trying to figure out how to get it to work. But anyway, so I'm checking timing and everything like that, all the basic stuff that you're supposed to check. I couldn't figure out. I called Haltech, told them what I checked, which is kind of the basics, right? Spark, fuel, is your timing, correct? And after I told them, literally after I told them everything that I'd done, they said, all right, cool. Well, let's go ahead and gain access into your ECU. Let's see what we got. They literally remotely accessed the ECU, and they adjusted, looked at a few things. All right, start it now. Still not starting. And they walked it through, and literally within 5 minutes, it was literally just the way that the idling duty cycle was set up. I didn't have enough duty cycle to be able to keep the throttle body open for it to idle. They made some basic adjustments. Boom, started, and I was good to go. I was able to do the basic idle logs and things like that for my eTuner and get that all worked out, right? So we do it differently now, but that initial customer support, I don't know if Link has that type of remote access your ECU or even someone to call. I think you got to call a dealer for Link, and then they're responsible to help you, but they just sold you the ECU, so why are they going to help?
So I don't know. I can speak. I've had a lot of interactions with Haltech customer service, and obviously I'm going to say they're great because they've always treated me great as one of their dealers here in Asia. My interaction with Link, and I've tried to carry Link a few times actually in the years past. It hasn't been the same. We'll just say that. A little bit harder to get a hold of, a little bit less responsive, a little more gruff around the edges. I don't know. Haltech always seems very happy to assist with their products and go out of their way. Again, my experience.
Yeah.
So let's jump back over to this because I kind of want to cover the whole standalone thing. Sorry if I'm boring you guys with my rambling. All right.
One thing, if you don't mind, real quick, you mentioned how your sensors and things like that are specific to the OEM ECU, and then the Haltech's not. Something that we didn't touch on, which I think is really important in this day and age, where we have 25-year-old plus cars. These are the types of cars that we're going for. They're not really making these types of cars. A lot of parts are going discontinued, right? So when you have an OEM ECU, if you have a discontinued mass airflow sensor and it goes bad, what are you going to do? You know what I'm saying? But if you have an aftermarket ECU, not only do you have speed density, but like we were talking about, you touch bases a little bit the aftermarket like the sensors and things like that. If you wanted to, you can get a newer model, like let's say Subaru mass airflow sensor. If you had an ECU like a Haltech Elite inside of the like a GC8, you can utilize a newer mass airflow sensor with an older car, right? So it helps out a lot. This little guy over here is getting all crazy on me.
Yeah, and it's
little man.
a great point. It's a great point, Kevin. Now, talk about trackside, right? Well, because at the end of the day, motorsports is geared for track cars. I know a lot of us are building street cars, but if a car goes down at a racetrack, it's a huge deal. A lot of money is put into that. And with something like a Haltech or a Standalone, I can find any sensor that fits in the hole and I can connect wires to. And as long as I have the data sheet, right, the voltage tables or the resistance tables for that sensor, I can go in, program it, and that sensor is now good to go on the car. We can get the car back to where it needs to be.
And it's relatively quick too.
Right.
It is.
So we talked about WinOLS, and anyone that has an actual interest in reflashing, I would encourage you to research this. Horsepower Academy has an entire course on this now, which is pretty cool. But essentially what WinOLS does is it pulls that raw data that we've been talking about, the definition files, or the raw data, and it helps you create these definition files, right? So in the picture, you can kind of see the hexadecimal coding. It looks for patterns within that coding and is like, hey, this is a table. Now it's on you to figure out what that table is and what the scalar is in that table. And it's pretty in depth, but if you can master WinOLS, you can technically reverse engineer any car. Right. So just a tool out there for you guys that may be interested in this in the future. So
to speak on sensors really fast, can you use whatever sensor on a Haltech? Because I've heard that you have to buy the Haltech sensors to run on a Haltech ECU, but a Link can run whatever as long as there's a calibration table.
No, that's absolutely not true. You can run any sensor as long as you have the calibration table.
I think you muted yourself.
Did I mute it?
No, I think
No, sorry. I muted myself because I just I'm driving, so I'm trying not to get all the road noise.
Yeah,
and I just
breaking the law. All right.
But,
so no, you can run any sensor as long as you have the calibration table. Same as pretty much any ECU.
Okay. Yeah, no. So I guess to kind of backtrack a little bit, and I'll try not to get too far off topic here, but the price of a Haltech versus the price of a Link. Because the Link will plug right up, right? No matter what, because Links plug directly into, or at least for now. Anytime I'm going to speak, it's going to be generally in Subaru experience, because that's obviously what I'm going here, right? So a Link will directly plug in just like the stock ECU.
Yes. So will a Haltech.
No plug and play harness to buy.
Sure. I see where you're going with this. Okay. Yes, it will plug in as long as they make a plug and play board for yours. A Link also fits inside the OEM case, which is important in some countries for visual inspection. My counterpoint to that would be when you buy a Haltech now with the Elites, you're getting the jumper harness, the plug and play harness, and you're getting a universal Elite 1500, 2500, 750, whatever. So if you do change chassis or you wreck your car or total your car and you move on to a different platform, you can take that Haltech with you and either wire it in if it's not plug and play supported, or buy the plug and play harness for a couple $100 on the new chassis and you're back in the game. Versus a Link, that board is only going to have the plug and play header for that specific ECU.
All right. No, I see where you're going with. Like I said, the only reason I'm asking a lot of these questions is because I am tossing out the idea of Link or Haltech.
Sure.
The stock ECU, like I said, I am tuning with it. It is a placeholder. It is not a permanent solution.
Yeah, and we talk in the messages all the time, so we can definitely discuss the Link Haltech plug and play options a little more. I personally think having a universal ECU with a jumper harness makes a lot more sense than having a hard soldered plug and play header on the board itself. So I can use that ECU for other things. My opinion. So So jumping over here real quick, kind of to talk about it. So what we've been talking about open source or reflashing options. We've been talking open source, right? We've been talking ECU Flash, ROM Raider, EvoScan, WinOLS to reverse engineer. I guess I should have put WinOLS in proprietary. That's my fault, typo, because it is $1,000 for that software. But proprietary, right? People don't think of it this way, but things like ECU Tech, very popular with the Z chassis, the 350s and the G37, 35 series, things like that, ECU Tech, right? You have to buy their packages and their coupons or their coins or whatever they're calling it today to reflash, and they have maps, etc. Everyone here, I believe, is familiar with like the Cobb access ports. Same thing. It's still just reflashing. You just get a nifty visual display with it. The KES, which has a list of something like 10,000 supported ECUs that you can open source flash with. Some are done similar to the Tactics cable through like OBD. Some require the ECU to be taken out of the car and put into a bootloader mode, and some require the actual chip to be extracted from the circuit board and put into a chip reader to reflash that chip. And then on top of that, not all the definition files are fully developed, so you may have to finish defining some of those maps yourself. HP tuners is another one, very popular with the LS guys. And then Niztune, of course, I've personally used, had a very weird K factor thing I had to figure out, but again, a proprietary reflashing. Requires hardware, right? No matter if it's proprietary, you'll get the hardware with the proprietary package more than likely. Open source, you guys are familiar. You need the Tactics cables, the jumpers, the individual adapters for whatever chassis you're working with. And then it's a two-way OBD interface typically. Versus standalone options, right? So some of your standalone options kind of going from cheapest to most expensive would be like AAM, Link, Haltech, Motec, Imtron. Going more super high-end motorsports would be Cyvex, Bosch, Life, and Magneti Marelli, which if you can afford a Magneti Marelli, you're probably not listening to us blabber on because it comes with an engineer.
Oh, wow.
So some of the Haltech features, right? You guys can look this up on Google on Haltech's page, but it lists out all of the ECUs currently in the lineup, and then shows you like their data logging capabilities, how many CAN buses they have, how many cams they can control, all these things. So if you're in the market, I suggest you find this table. Thomas is a great example for you. Find this table, put it next to the link table, and actually look at what you're getting for your money. How many injector drivers do you have? Ignition drivers, cam control, what motorsport features do you have? And really see where your money lies with that. A bigger example, right? Kind of jumping more into the motorsports. So an Imtron KV16. So I'm an Imtron dealer. I personally use a KV12 in my 3-rotor RX-7. The KV16 is one step up, and the biggest difference is injector and ignition drivers. But I can essentially control 16 channels of fuel and 12 channels of ignition out of this ECU. So up to 16 injectors sequentially fired. 12 ignition housings, right? It's aluminum casing, has 32 megabits of data logging memory on board. It has a 4-channel oscilloscope built on board, so I can look at the electrical signals for 4 channels within my entire engine. Anything that the ECU can see, I can look at the waveforms on. Dual wideband controllers built in, dual digital knock control, Ethernet communications, has an internal G-axis or G-force meter, which you can use for traction control. And then you look at how many it can log between 1 hertz and 500 hertz, data logging, 1,200 channels of data logging, right? So you can kind of see, like, the point being, if you look at the capabilities of these standalones, and yeah, you're talking a ton more money, but you're also getting a ton more in the realm of diagnostics, and that may be worth it to you, especially if you're into motorsports or you're building a track car. It may not be worth it to you if you're just adding injectors, or you just want to pick up some torque. ECU flash for a couple $100 for a cable may be the move for you. It really comes down to your individual builds, your budget, your needs, and honestly, your knowledge, right? If you're going to do it yourself, or if you have to pay a tuner, because if you have to pay a tuner, you're more than likely going to have to rely on what they're comfortable with. And then this is just a screenshot of the Haltech NSP oscilloscope for those that aren't familiar, but I believe they're looking at trigger waveforms here. Yep, so trigger input state and then the trigger voltage. So troubleshooting, right? We had a Hachiroku a while back, did not start. Custom harness, custom Haltech, and we eventually got it started. But we had to use this scope, and basically the distributor inside, which has the teeth that makes the trigger in the home for that particular engine, it's not that it wasn't working, it's that it was so old it wasn't outputting enough voltage. And we were able to diagnose that through the use of an actual external oscilloscope as well, a picoscope, that it was working, but it wasn't working strong enough for the Haltech to see it. So that really can come into your diagnostics and troubleshooting if you're building custom cars, or you're going to be using your car for motorsports where you need to be able to troubleshoot trackside, and you may not have access to an entire shop worth of equipment.
Yeah, that's actually a really good, because the ESP didn't have that, and that's just on the new stuff here. But like, so basically, like the reluctor sensors is typically what you have that type of issue with, right? So you have a zero, or it goes below zero, and then at 5 volts, there's kind of a jump, and then that basically makes the signal, and that's how the ECU is reading it, right? So if you have like an old setup, like an old Hachiroku that doesn't have the voltage properly, the ECU says it needs to at least go to for example, it needs to go up to 2.5 volts and then drop down to, you know, I don't know, at least 0.5 volts to be a signal. It's not in that range. Like, not only in older cars like that, you have issues where, like, actually once I had in the Legacy, same car that I was telling you about, GC8 with the Haltech setup with the reluctor sensor, the higher the, what would you call it? Like, I guess you could say RPMs, but it's really how many times, right? The higher the voltage will go as it's going down faster and faster.
On a reluctor sensor, yeah. So it's the faster it spins, the more voltage it actually outputs.
Yeah, so you have a higher jump, which doesn't necessarily always mean it's going to drop down as much also. So you have to kind of create with Haltech sometimes the custom graph, right? Where you kind of, with RPMs, you can kind of create it so like you can lose some trigger losses. So this is kind of like I don't know, for me, it was kind of a bummer. I didn't like to have to try to dial in the aftermarket, you know, the OEM, you don't got to do that, you know? So
right. But the counterpoint I would make with that, right, is again, it's strictly talking OEM, not saying with EC flash, right? Not going into that realm with what's been modified, but strictly speaking, if your trigger wears out because it's voltage reluctance sensor, your ECU has that same table in it. So if it falls outside the parameters that are configured in the ECU, you're going to have the same issues. But with the Haltech, you can go in and you can build your own table for your arming. What you're talking about is your arming voltages, right? Your arming thresholds and your arming voltages.
Yeah.
So that's the same issue we had in the Hachiroku. No matter what we did, we couldn't get the voltages to stay high enough, and they were fluctuating so much. So unfortunately, now the answer for that for everyone listening is to get a trigger wheel and a Hall sensor and put it in your Haltech or your Link or your any other ECU. Insert here, custom trigger wheel, update that 40-year-old technology.
Yeah.
So
did it run with the OEM ECU? Was it just the aftermarket ECU where it started?
No, well, we couldn't go back and test it with the OEM ECU. Unfortunately, this engine had been rebuilt by a person in Okinawa at home, essentially, and there was major engine damage on that build.
Gotcha.
I don't want to get into specifics because I'm not trying to call anybody out here on the internet. But there were some errors made in the mechanical assembly of the engine when that person had rebuilt it. And I believe it was their first time rebuilding an engine. But essentially piston clearance to wall. There was some dragging, and because the engine had been bored over so many times, our only choice was Supertech pistons, and they were like an 11-to-1 compression ratio static. It was the only bore we could get for the engine at that time. It was either that or replace the entire engine assembly, right, with a new block. And as you know, Hachi parts are getting pretty hard to find. 4AGs in particular are just getting harder and harder to find. So we chose to do that and then basically run a thicker head gasket to try and bring that compression back down. However, we needed to increase the injector size to make up for that compression so we could properly tune it, which led down the rabbit hole of, okay, we need to put Haltech in. To put a Haltech in, we have to get an engine harness, right? We have to pin a custom harness in. So then we had modified the wiring harness, and we couldn't plug the OEM ECU in anymore. So kind of just the worst case scenario from the time the car showed up at the shop to the time the car left the shop. Yeah, I believe the car is running fine now, but they went to a custom trigger wheel with a Hall sensor to eliminate that whole distributor mess.
Yeah, which is again something that you could do that's really cool because like OEM ECUs, for example, like the RPM range, like for Subarus, if you have a specific RPM going past that RPM, well, I don't know if that's the case, but I know like with Haltech, when you go at a higher RPM than what the OEM stuff is, sometimes you can get trigger issues and whatnot. But another thing that you're talking about, so the reluctor versus Hall effect, right? So the 3-wire versus 2-wire,
Yep.
you have a positive and a negative, and then you have the signal, which works outstanding, right? So if you use something like that for the cam sensor instead, you have zero issues typically.
Yeah,
with like,
because the Hall effect's gonna be digital, right? So it's a square wave versus a peak and drop.
yeah. So it's fixable still, even if you don't want to use the what is it? Oscilloscope.
Oscilloscopes. Yeah.
You know, you can always go Hall.
Anyway, that concludes what I have to talk about. Kevin, anything you want to add to this discussion, or anyone else? Jump in, please.
Say, I got a question.
All right.
How do you guys feel about the external control units when it comes to OEM ECUs and standalone ECUs? For instance, say like Bully Dog or Cobb access ports.
So again, like the Cobb access port, like we talked about, right? It's essentially just a reflash. The access port allows you essentially the access port save multiple maps or tunes within it, and then you could switch those tunes as an end user with the visual external controller. So I think it's great as long as you have the tune set up for it. It's been properly dialed in for your car, then yeah, it's awesome, right? You don't have to break a laptop out. Haltech actually just added an app for the Nexus. The Nexus has built-in Wi-Fi, so now they have the Haltech app. You can go in and do a lot of data logging and data viewing and assorted things like that. So it's kind of like an external controller in that sense too. It's also been done in the past with the larger Haltechs that have the dual CAN bus, getting an OBD2 or an OBD adapter with a Bluetooth, essentially OBD2 dongle, and then in third-party app you can connect to your Haltech via that way for the older elites that didn't have Wi-Fi. It's actually on the Haltech YouTube channel, their knowledge base on how to set that up. So you can have a Haltech app on your phone to do essentially the same thing.
Well, I mean, it's like, can you hook up an Apex-E Power FC controller to a different standalone ECU?
No, it's specific to the Apex-E.
So same with Bully Dog, you can only link to an OEM ECU. You can't use that on a standalone system.
I would assume so, yes.
I do believe that there's a company in Australia that makes like displays that can output stuff kind of like a Cobb access port to multiple different ECUs.
You're talking, so I think what you're talking about is PowerTune?
Yeah, I think it's PowerTune.
Okay, so a little bit off topic. So you kind of have two different categories there, right? You have an interface, like an old school interface, like Rob brought up the Power FC, which had a controller that plugged in via what's this? Is a serial PS2? It's like the old keyboards, right? Back in the day, straight into the ECU. Now with CAN bus, right, and that's what PowerTune uses is CAN bus. As long as the device has the CAN bus protocol, so Haltech has the Haltech protocol, but for example, the Haltech IC7 has AM Link, Haltech, and a few others, right? And if you look at like the AIM dashes or the AIM dashes, they have dozens of CAN bus protocols. Essentially, it's addressing and encoding that communicates just like a network, like binary almost, to put it very, very simply, right? Binary in their own languages. So PowerTune is universal. As long as it has a CAN bus that supports the ECU, then it will display the data from the ECU. And it sounds like our next Q&A should be on CAN bus.
Ooh.
That's a good one.
So I need to get a little bit more technically smart on CAN bus.
Yeah.
I've done it a lot, but yeah, my experience is limited to Haltech, Motec, and Mtron with CAN bus essentially, and it gets pretty in depth. Big Indian, little Indian, hexadecimal addressing versus decimal addressing, things like that. So
standalone. I'm assuming standalone is a lot easier to tune when you plug in a laptop versus if you could hook up a quick little, external device to make tiny changes that you can do yourself.
Well, I would argue that if your tune is on point, then you shouldn't have to make changes as long as the engine hasn't changed, right? And that's what I always tell people is the tune didn't change, your engine changed. Your compression.
Classic.
Engine.
Classic Seth.
Well, because the tune doesn't change.
That's very true.
Right, but something else changed, and that's why the tune is no longer correct. Right now, within reason, if nothing else has changed within reason, then your closed loop controls in a modern ECU should be taking control of that. Right, temperature changes, coolant temperature, things like that. Your wideband making minor fueling changes to keep your target AFR at your target. Things like that should all be handled by the closed loop. You as a end user should not have to make changes or modifications. Now, things like having different boost settings, for example, is an example of when you would do that, though, and want some sort of external controller, whether that be a rotary switch or a CAN bus button on a CAN bus keypad, something like that, so you can make end user changes that need to be changed. One of the things that I like to do with my customers is set them up with emissions tunes for annual testing. So we'll have a different fuel map that we can trigger over with a rotary switch or an input-output switch.
Nice.
Anything else?
Real quickly before I hop off, so I know Link has the availability to do a CAN bus controller, and then you can run that CAN bus controller to a head unit. And then with that head unit, you can like control your boost levels. So you can select like a target boost level straight from your head unit and just straight adjust it from there. Is that possible with a Haltech too?
So the short answer is yes, it should be. However, I don't know if Haltech or third party has made an interface to a head unit. Right, that's kind of the question I'm not sure of right there on the head unit itself. But essentially, CAN bus is just two-way protocol.
Right.
It's just communication between the two. So as long as device A, the adapter, has the right protocol, Haltech protocol, and can talk to the ECU, and the ECU can talk to it, you have what's called a HID or a human interface device, kind of like a keyboard or mouse, in this case, the head unit, or a CAN bus keypad, then yes, you could. I just don't know if there's a head unit that's compatible, right? Like I think the PowerTune has like a touchscreen maybe, and I know with the new update, the IC7, there's some changes coming that are pretty interesting as well. So stay tuned for the new IC7 firmware. It's massive changes.
Essentially, ECU is like an NSP firmware inside that thing. That's
yeah, they're completely changing the IC7 with this new firmware. They're introducing it in stages, but you'll be able to program the IC7 through NSP now instead of through ICC. So you won't have to have different software anymore.
I saw that.
So yes, Thomas, the answer to your question is yes, it should work. Yes, it should be possible. I do not have the specifics for you at this time.
It's no problem. I was just curious because like I always thought it was really cool how like because like Logan Bundrick here has that to and hold on, there's an aircraft going overhead.
So I would say, in summary, how do you feel about the differences between standalone ECU versus OEM ECU? Like, what are your opinions on them?
So I think personally, if your budget can swing it, standalone is the way to go every time. Because you're not, and I'm going to say it again, Kevin, you're not hacking something. You're using a purpose-built piece of hardware, right? And a pet peeve of mine is you have people that will spend thousands and thousands of dollars on parts and bolt-ons and extraneous crap they don't necessarily need to reach their goals, but then they want to save where they choose to save money on their budget is in their computer, in their ECU, which is essentially the brain of your whole car. It's controlling all those other systems that you spend all this money on. So I mean, it's kind of a pet peeve of mine in that sense.
Yeah,
now,
for me,
like, yeah, go ahead, Kevin. Sorry.
Yeah, no. So of course, because I deal with only Subaru, so for me, ECU flash and just the way that it is proven itself with the OEM stuff. Little man. Yeah, the price point, and then like Seth was saying, you know what you could do. I kicked him out of the room. What you can do with the OEM ECU, like you said, you can get good tunes with them, right? So for me, I would always say it's like 9 times out of 10, like what Seth is talking about on all these different levels is like the aftermarket ECUs, what you could do with them, switching them from one car to another car and things like that. It's like I don't want to make it sound like it's a next level thing, right? But there's a lot of the guys, especially in the Subarus, where it is just like a very simple, like your ID 1050Xs, pick your turbo, exhaust manifold, intake. There's nothing really that crazy, and the OEM ECU can handle it. So it's like, if you're happy at that level, and a lot of the times these guys are, the OEM ECU can do outstanding. So it's kind of like, well, why are you going to get a Haltech when you're trying to get, an injector and injectors in a turbo? It's kind of like going overboard in some sense because the OEM ECU is so well. I would still say I've done way more OEM ECU stuff, like even merges. Like we'll take a newer engine and put it inside of an older GC8. And one big reason is because the OEM ECU is reflashable, and it works out really well. Even though I've tried, like in the very beginning, I was always telling guys, hey, you can do the merge, you have a newer setup, you're still going to be strapped to what that ECU can do and the sensors that it comes with. And the funny thing is, the aftermarket ECU, whether it's Link or Haltech, is cheaper than a merge, right? You're buying an engine, you're buying a power steering set. You're getting all these different types of things to be able to put that engine in. Even a basic EJ205 inside of a GC8 is like $4,500 because you're getting an engine and so much more. The harness, the ECU, then you got to pay me to take two harnesses and make one harness and then reinstall it in the car. When you can just do an OEM ECU or standalone ECU. I don't know, man. These guys love to get the merges.
I don't know. I guess the best way to sum it up, and me and Kevin are probably in agreement on this, is it comes down to your build. Comes down to your build, your goals, your budget, your tuner, right? If you're using a tuner or a mechanic, all those factors play in. Yeah. So I can't give you a blanket answer on that. I prefer a standalone. I prefer a purpose-built piece of hardware. And I'm by no means am I saying that you can't be successful with an OEM reflash, especially on a lot of things. If you're at a motorsport level, if you're actually competing, I would argue that you should just bite the bullet and go standalone. For a ton of different reasons that is a whole different subject that we kind of touched on some of the things with sensors and interswappability and things like that, but it doesn't mean it's the right answer for everybody.
Yeah, and I was going to say it all depends on what you need. For a fantastic example, when my car randomly stops running during JCI, we Bluetoothed into my standalone and was able to get it running. And then a couple of days later, come to find out, Seth got it running off of two secondary injectors. But you obviously need your primaries, but in a Bluetooth scenario there, where he's in a different location and you're in a crunch, if you're doing a flash-in OEM ECU, that's not a possibility to get done. With a standalone, that is a possibility.
Yeah, that's just a good example of kind of, I don't want to say it's making it work, right? And sometimes in motorsports, especially, or in Colton's case, annual inspection to try and get a license plate again. Sometimes you just have to make things work. Yeah. I think me and Kevin can both attest to being on the side of a mountain, zip tying drive shafts together and things like that back in the day, right? Like you'd be amazed what you can find in a pit crew at a circuit track happening to keep the car running to get it across the finish line. So anyway, I think that covers it. Going once, going twice. Kevin's kids wants his attention. All right. Hey, thanks for joining us, guys. If you enjoyed this, please let me know. You shoot me a message or email or whatever. Kevin, thanks for coming out and supporting this as well with your experience doing OEM flashes, especially in the Subaru community. And hopefully we can do this again on another subject.
Yes, sir.
Excellent. Thanks a lot, guys. This was awesome.
All right, guys. Take care. Yeah.